So we're on to 2021, paper 1, question 3. So the diagram shows a cuboid with dimensions x, y, and z centimeters. The area in centimeters squared of 3 of its faces are shown. And we're asked to find the volume of the cuboid in the form a root b centimeters cubed, where a and b are elements of the natural set. Okay, so I suppose the first thing to understand, it says it in the question, but just to be clear, the measurements here are the area. So the 2 root 2 is the area of that front face. And then, of course, we have 8 root 6 is the area of that right-hand side, and 4 root 3 is the area of the top section. And then, of course, a cuboid in total has 6 sides. So each of those are repeated, you know, matching right with left, top with bottom, front with back. Now, anytime I think of volume full stop, when we think of, you know, the definition of volume, normally I guess we think of length by width by height, and there's nothing wrong with that, length by width by height. But when we think of something that might be an irregular shape, now I know this isn't an irregular shape, but if we're talking about an irregular shape, usually what we want to know is if we have the area of the front section. So if we have, so let's say I draw something here like this. So if I have the area of the front section, what we call the cross section. So all I have to do, if I know that, all I have to do is multiply by how far it goes back. I describe it usually to the juniors as if you're putting it through the meat cutter in SuperValu. Every slice is the same. So it's kind of like saying, if I know the area of the first slice, well, then the whole way back, it's going to be the same. So in this case, because I have the front face, now if you want, you can just consider that length by the width, you know, but essentially, if I know the area of the front and I multiply it by how far it goes back, that should give me the volume. So the volume is really 2 root 2 multiplied by y. Okay, now if you want, you can say x times y times z, but still x, like if you wrote it out as x, z, y, length by width by height, the xz part, so because that's z as well, is still 2 root 2. So instead of writing out kind of length by width by height, what I've done is I've taken the area of the front. So I've taken the area of the front, which is your cross section, and then I've multiplied it by how far it goes back. So there's a formula for that in your log tables, which we will get into more, I suppose, when we do that chapter on area, volume, and all that. So we have 2 root 2 times y. Now, that should give us our answer, but of course, we don't know what y is. Now, there's different ways to do this. The way I'm going to show you might be a little bit longer, but for me, it just makes a bit more sense rather than trying to take a shortcut. But if you have your own way of doing it, that's fine as well. But anyways, I'm going to just do it the way I suppose logically I think of it. So I don't have y, so I need to think about, well, for example, z times y, I know that is 8 root 6. And I know, for example, x times y is 4 root 3. So I suppose what I'm thinking is, if I write them both in terms of y, so the top guy would be y equals 8 root 6 over z. The bottom guy would be y is equal to 4 root 3 over x. Now, because they're both equal to y, well, then they should be equal to each other. So I have them equal to each other. Now, this is still obviously an issue because I still have 2 different letters. So what I need to do is somehow make them into the same. So for example, if I get rid of the z out of there and make it into an x, well, that's going to help because then I'll have it all in terms of the same variable. So how would I do that? So, well, again, we go back to what we know. So we know that x times z is 2 root 2. So z is the same thing as 2 root 2 over x. So what I'm going to do is I'm going to replace the z with 2 root 2 over x. So I'm going to have my same thing again. I'm going to have my 8 root 6, but over this time it's over 2 root 2x. I know that doesn't look very pleasant at the moment, but we'll sort it out in a minute. And I have 4 root 3 over x. So what I'll do is I'm going to focus on the left-hand side for a moment. So I think I'll write it out long ways. So I'm going to do 8 root 6 over 1 divided by, so just making use of my division symbol, just so that I can kind of see it a little bit easier. So of course we change division to multiplication and we invert what follows. So that's first year stuff there. So we end up really with 8 root 6x over 2 root 2. Now let's see if we can make that a little bit better before we piece it back together. Well, 2 will go in there 4 times anyway. Now, root 6 could be rewritten as root 3, root 2. And underneath the line, I have root 2. So I could cancel them as well. So what I have now is I have 4 root 3x over 1, essentially, because that's all I have left there, is equal to 4 root 3 over x. So now when I go to cross multiply, I have 4 root 3x squared is equal to 4 root 3. So x squared is equal to 4 root 3 over 4 root 3, which is 1. Now, if x squared is 1, well, then x is the root of 1. Now, in this case, it's not plus or minus because it's a measurement, so it has to be positive 1. So x is 1. Now, if I know x is 1, I can go back here and I can say, okay, now I know that x is 1. I know that y is 4 root 3. So I can replace that back where I had my volume. Volume is 2 root 2, and I now know y is 4 root 3. So I know my volume is in fact 8, which is 2 by 4, root 2, root 3. And then I can write that as 8 root 6. So that's my answer, and it's in centimeters cubed because it is volume. And I'm supposed to have my answer in the form a root b centimeter cubed. So I do have it in that way. It's supposed to be natural numbers. It is. 8 is a natural number. 6 is a natural number. So we're all good. And the answer is 8 root 6. I know that looks a bit long-winded there. And there's a bit of work there with the surds. But overall, my line of thinking is I rewrite it in terms of the same variable, which gave me that line. And because I allowed each of them to equal y, then I rearranged to get rid of the z, which made it the same as that. I made it all into x. And then I found out what x was. And that was a key step because once I knew what x was, I was able to know what y is. And then I filled my y back in here. So that was the process. The second part, what is it? Given that f of x is equal to 3x squared plus 8x minus 35, where x is an element of or, find the two roots. In other words, where f of x equals 0. Well, this is very straightforward. You can either use your minus b formula here, or you can just do your factorizing and null factor theorem. Either way, you're going to get the same answer. I think I might just do it using my trial and error. So I have 3x and x. Now, the minus here means the signs are going to be different. So one's plus, one's minus, or the other way around. I'm not sure yet. I need two numbers that multiply to make 35. But when I pop them in, I need to get positive 8. So I'm thinking 7 and 5, I think will work. Minus 7x plus 15x. Yeah, that's 8. So I'm done in terms of my factorizing. Now I do my null factor theorem, which means I allow each factor to equal 0. So 3x is equal to 7, x is equal to 7 over 3, and x is equal to minus 5. So there are my two answers, and I'm done.